The moon, Earth's closest celestial neighbor, has been a source of wonder and mystery for humanity for millennia. Its surface, scarred by craters, volcanic plains, and mountain ranges, tells a story of cosmic impacts and geological processes. Yet, beneath its stark beauty, the moon's history is as fascinating as it is complex, influencing not just the Earth, but also shaping the future of space exploration. The moon is thought to have formed around 4.5 billion years ago, shortly after the Earth was born. According to the giant impact hypothesis, the moon was created from the debris left behind after a Mars-sized body, named Theia, collided with Earth. This colossal impact ejected large amounts of material into space, which eventually coalesced to form the moon. This theory is supported by evidence suggesting that Earth and the moon share similar isotopic compositions, especially in terms of oxygen isotopes. In the early days of its formation, the moon was a geologically active world, experiencing frequent volcanic eruptions and massive meteorite impacts. The surface was marked by vast oceans of molten lava that slowly solidified to create the large, dark plains known as the Lunar Maria. These regions, which make up about 16% of the moon's surface, were formed by ancient volcanic activity and are visible from Earth. For centuries, astronomers believed the Maria were seas, and that's why they were named Maria, the Latin word for seas. Today, the moon is a geologically inactive world, with no significant volcanic activity or tectonic movements. However, its surface is still marked by countless craters, the result of meteoroid impacts that have occurred over billions of years. One of the most famous craters is the South Pole Aitken Basin, one of the largest and oldest impact basins in the solar system. These craters are essential for scientists studying the early history of our solar system, as they offer a glimpse into the violent past of the moon and the other planets. The moon's gravitational pull has a profound effect on Earth, particularly in the way it influences the tides. The moon's gravity causes the Earth's oceans to bulge, creating high and low tides as the moon orbits around the planet. This has had significant implications for life on Earth, particularly in shaping marine ecosystems and influencing the behavior of various species. The moon's gravitational forces have also contributed to the stabilization of Earth's axial tilt, helping to maintain a relatively stable climate over long periods of time. Without this stabilizing effect, Earth's climate could have been much more erratic, making the development of life, as we know it, much more difficult. Throughout history, the moon has inspired myths, legends, and scientific inquiry. Ancient civilizations often worshipped the moon, associating it with gods and goddesses. In Greek mythology, the moon was personified as Selene, who was depicted driving a chariot across the night sky. In many cultures, the phases of the moon were used to measure time, with lunar calendars being some of the earliest methods of keeping track of months and seasons. The exploration of the moon reached a significant milestone in the 1960s and 1970s with NASA's Apollo program. The Apollo missions were a testament to human ingenuity and ambition. The most famous achievement came in 1969 when astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the moon during the Apollo 11 mission. Armstrong's iconic words, "That's one small step for a man, one giant leap for mankind," echoed around the world, marking an era of scientific and technological achievement. The Apollo missions not only put humans on the moon but also provided a wealth of scientific data that has expanded our understanding of the moon's geology, composition, and history. The Apollo astronauts brought back over 800 pounds of lunar rock and soil samples, which have been studied for decades. These samples have revealed important details about the moon's composition and helped to confirm the giant impact hypothesis. They also provided evidence of ancient volcanic activity on the moon and gave scientists a better understanding of the moon's formation and evolution. These missions were crucial in advancing our knowledge of the moon and the solar system as a whole. In recent years, the moon has once again become a focal point for space exploration. NASA's Artemis program aims to return humans to the moon, with the goal of establishing a sustainable human presence there by the 2020s. The Artemis missions plan to land astronauts on the Moon's south pole, a region that is believed to contain water ice, which could potentially be used for fuel or drinking water for future missions to Mars and beyond. NASA hopes that these missions will pave the way for deeper space exploration and serve as a testing ground for technologies that could be used on longer missions to Mars and other destinations in the solar system. Private companies such as SpaceX and Blue Origin are also developing their own lunar missions. SpaceX's Starship, for example, is being designed with the goal of carrying cargo and humans to the Moon and eventually Mars. The private sector's involvement in lunar exploration could accelerate the pace of space exploration and open up new possibilities for space tourism, mining, and even colonization. The Moon is also a potential source of valuable resources. In particular, there is growing interest in mining the Moon for water ice, which is present at the lunar poles. Water is a critical resource for human exploration of space, as it can be converted into hydrogen and oxygen for fuel or used for drinking water. The Moon's surface also contains rare minerals such as helium-3, which could potentially be used in future nuclear fusion reactors. While mining on the Moon is still in the early stages of development, it has the potential to revolutionize space exploration and provide valuable resources for future missions. The Moon continues to captivate and inspire people around the world. Its influence on Earth's tides, its role in stabilizing our planet's climate, and its rich history make it a key component of life on Earth. The Moon is not just a distant, lifeless rock in the sky. It is a vital part of our existence, shaping everything from our environment to our culture. As humanity looks toward the stars, the Moon will continue to be a symbol of our progress and our desire to explore the unknown. Its story is far from over, and as we continue to study and explore it, we will undoubtedly uncover more secrets and mysteries that will enrich our understanding of the universe.